We sent the samples off to a commercial laboratory for chemical analysis, which is what you normally do. But we are going to now show you some of the key steps in doing a chemical analysis so that you know what goes on there. Essentially, when you do a chemical analysis, there are two steps. First, you have to extract whatever chemicals there are in the soil into the solution. That's called an extraction. There's a variety of ways you can do it using different types of extractants. And then when that extraction comes back, we have to determine the concentration of whatever we're interested in the solution.
We're going to be preparing the two extractant solutions now, and we're going to be using two solutions. We're going to be using deionized water, which represents the soil water that would be in the soil naturally. And the second one we're going to be using is 1 mole KCl, which is a powerful ionized solution, which will force what acidity is in the soil into the solution. What we're going to be doing is we're going to be taking 10 moles of the soil, and we're going to be putting it into our tube. To this, we're going to be adding the deionized water, and we're going to be filling it to 25 moles. It's now there. The second extractant solution we're going to be using is this 1 mole KCl, and we're going to be similarly adding soil to the tube, 10 moles of soil. Adding the extractant solution. To 50 mils because of the ratios that are necessary. Putting on the lid, important when you're going to be shaking something. We could do the extraction using filtration, but this takes a very long time. So instead, we're going to use the centrifuge for this. The second part of the analysis is to measure the element of interest, which in our case now is a hydronium ion, H+. We are going to be using an automated pH reader to do this. And before we begin with our actual soil analysis, we must calibrate this meter. We're going to be using a pH buffer solution 4.0 and also a pH solution of 7 to calibrate the reader. We're also going to be using a temperature probe to adjust for temperature. Sorry.
We'll be correcting the pH for temperature.
Correcting the pH for temperature?
Automatically corrects for temperature. Okay, ready when you are?
I'm ready.
And action.
The second part of the analysis is to measure the element of interest, which in our case now is the high. The second part of the analysis is to measure the element of interest, which in our case now is a hydronium ion, H+. We are going to be using an automated pH reader to do this. But before we begin with our actual analysis using our soil, we're going to have to calibrate the machine. We're going to be doing that using two pH buffer solutions, pH 4 and pH 7. We'll start with the pH 4. And that is 4.01. We'll also be putting in a temperature probe to correct for temperature. Between the solutions, we have to clean it with the deionized water solution. Thereafter, we go on to the pH 7. 7.01. Similarly, we also correct for temperature. The sample is now back from the centrifuge, and it's now time to record the pH of the sample. we're going to be placing the probe into this clear part of the supernatant above the soil pellet at the bottom. It's fully immersed but not touching the pellet. And the reading is 5.82. Here what I have is a small sample of the soil solution from the centrifuge. To this, I'm going to be adding 2 drops of the indicator. I'm going to be titrating out 0.01 molar NaOH, and at the point we get a color change, I'm going to be recording how much has titrated out, how much of the solution has titrated out. All the while, you saw that color change. It's now a soft pink color, and that was about 5 mils of the NaOH, 0.01 molar NaOH.